Okay, we were talking about covalent bonds. The atoms are shared by a pair, they share pairs of electrons. We have two types. Where they're shared equally is nonpolar. And if one has more electronegativity, which means it have more electrons than the other one, they may form a polar covalent bond. And water is a perfect example of that. And we'll talk about how magic water is later. In this PowerPoint, I'm also going to attach in the class, you can watch a bonding animation there as well. Then the other kind of bonds are ionic bonds. They are very strong and happen quickly, if you think of strong as quickly, but they break easily. They dissociate in water into the ions really, really quickly. So let's talk about what's happening here. This guy only has one electron in its last shell. This happens to be, if it has just 3 electrons, it only has 3 protons, so it's lithium, Li. And this guy over here has 2, 3, 4, 5, 6, 7, 8, 9. So that's number 9, which is fluorine. And it has 2 shells and 7 in the last shell. Well, this has got a lot more electronegativity over here. So it flat steals that electron off of this guy. He can't hold on to it. And now this one has 3 protons and only 2 electrons. 3 positive charges, 2 negative charges. So this is called a cation and has an overall charge that's positive. This guy stole an extra electron, negative charge, so it has an extra negative charge, and so this is an anion and it has an extra negative charge. Now, these stick together, not because they're sharing anything, but because this one's got a negative charge and this has a positive, and that's what attracts. All right, salt is the perfect example, and salt's this wonderful stuff that then builds those little crystals together by atoms in a very cubical fashion. This is what's happening in there with the sodium and the chloride. Very, very, very cool. And what happens when you put salt in water? It dissolves. You don't see it anymore. All of these ions come apart because they're not that strong, and so a negative chloride ion is floating around by itself, and a positive sodium is floating around by itself. This guy lost an electron, this one's got an extra one. And this is how it's formed. Same thing we were talking about. And then let's talk a few minutes about carbon. We are a carbon-based planet. Carbon is awesome. Carbon has 4 electrons in the last shell. That means it can do a whole bunch of stuff. That makes it very important for life. It can form single covalent bonds. It can do double bonds like I showed you in the oxygen gas. Sorry, my thing is cut off. It can do triple bonds like in nitrogen gas. Here's a single bond going on. It can bond with 4 different atoms. It can form chains. It can form branches. It can form rings. It can form, as I said, single, double, and triple bonds. And that is why we're a carbon-based planet, because of that reactivity. Let's talk about, briefly, I see I have a couple minutes left, so radioactive isotopes. We use these guys that have different numbers of protons. Those are the isotopes. So, same number of protons. These are the 3 isotopes of hydrogen. 1 proton, but it has different numbers of neutrons. We know that they decay at a certain rate. And since those bits are falling off are radioactive and can damage our DNA, we protect ourselves with lead and all this business. But we use those tracers very, very carefully in things like thyroid scans, nuclear medicine. It's slightly reactive. It doesn't last more than 24 hours. It's got a very short half-life, but it will light up places in the body that there's a lot of activity going on. Obviously looking for disease or cancer. Yeah, PET scan puts together a nuclear medicine with a CT. So they're really looking at some pretty amazing things. Here's someone with lymphoma in the chest. The heart is always big because it always takes up a whole bunch of stuff. But otherwise, these are the tumors going on up there. A PET scan can show Parkinson's disease. It shows functions going on in there. Normal Parkinson's, and this is pre and post treatment. Alzheimer's. Guess which one is? This one's Alzheimer's. This one's normal. Look at that activity difference.